Welcome to yet another exciting educational video brought to you by Vision Concepts Academy. So today we'll be looking at IGCSE Maths. The topic today is formula manipulation and rearranging making a subject or make a subject. So as our learning objective, we're going to understand the following at the end of the lesson. Identify is the subject of a formula. Number two, rearrange formulas to step by step to make a different variable the subject. Then number three, apply inverse operations correctly, adding, subtracting, multiplying, and dividing. Number four, arrange formulas involving brackets, fractions, and powers. Number five, handle more challenging formulas with multiple appearances of a variable. And finally, use your rearrange formula to solve real-world IGCSE-style question. All right, we'll dive into the video. If you are yet to subscribe to our channel, kindly subscribe and share for your friends to join what we are doing. So what is the conceptual explanation? A formula is a rule that connects variables. For example, speed formula. If I have speed S or V is equals to S over T, where V is velocity or speed, S is distance covered by the object, and T is the time taken for that movement. Okay, so these three things are connected together with this formula. So that is what a formula is. It's a rule that connects variables. So this is a variable, this is a variable, and this is a variable. They are all variables. But this is what we call the dependent variable. Dependent variable. Dependent variable. Why? Because it's dependent on this. Anything that changes on these two variables will change this. So, but these are known as independent variable. Independent variable. Sometimes you can have a constant inside this formula. Maybe something is not changing, you understand? But for this case, both speed and time is changing. For this to be also be changing. Okay, so this is independent because it's just not affected by anything. It just has its own value on its own. At a point in time, there's a particular speed. At a point in time, a particular speed. It's all about the two of them interact to give you this velocity. Okay, so the same thing again. I have another formula, the area formula. Area of a triangle. Area of a triangle. So this is another a rule that connects this thing is area is equals to half base times height, right? Where A is area, B is base, and H is height. So these formulas are connected. This formula is connected, or this formula is defining the rules connecting these variables. A is area connected to base and height. Okay. Now, the subject of this variable, the subject is the variable that is written alone on one side. So this is the subject at this point in time. Is a variable that is written alone. You understand? So this one is written alone on one side. Now, which side are we talking about now? The side is either the left or the right of the equation sign, equality sign. You understand? In maths, this is the reference point. The equality is the reference point. This is equal sign, right? Anything on the left side of it is called left-hand side. And anything on the right of it is called the right-hand side. So if I'm mentioning left-hand side, right-hand side, you know what I'm talking about. But any variable that is standing alone on either side is known as the subject. The subject. So it is subject over this. This one is subject over this. So the subject is the variable that is written alone on one side. In the case of this formula, it is speed, is the subject, and in the case of this formula, it is the area. So the big idea is whenever you do whatever you do on one side, of the equation, do to the other side. So for example, if you are trying to carry out operation, inversing operation, you will do the same thing on one side and on the other side. So I was talking about the rules, the big idea. So if, for instance, now, whatever you do on one side of the equation, do to the other side. So when you are using opposite inverse operation, for instance, if I have plus here, plus a on one side, I must make sure I have minus a on the other side. You understand? Inverse operation. Okay, if I have minus a, if it crosses, it becomes plus a. You understand? You will see where all these are applied. So, but these are inverse operations. So if I have times a, on the other side, it will be divided by a when it crosses, right? So if I have on this side divided by a on this side, when it crosses, it will be times a on this side. So if I have square, that is x square on this side, when it crosses, it becomes square roots on the other side, square roots on the other side. And if I have square roots on this side, square roots on this side, I'll be having square on the other side. And so on and so forth. If it is cube roots, it is cube on the other side, and so on. So think of a variable. Think of the variable you want as a box trapped inside layers. So the variable is a box that is trapped inside layers. So rearranging is simply removing the layers one at a time, doing the opposite of what the formula is currently doing. That is why we have this thing. Understand? If this one is trapped inside that equation or inside that expression as plus a, when you do it on the other side as minus a, you remove that one. So our aim is to gradually unbox whatever variable is trapped, so that we can leave a variable alone without other variable attached, known as the subjects. So we're going to look at step-by-step work examples. So if example one, you say make t the subjects. Make t the subjects. Okay, so if I have v is equals to d over t, make t the subject. So this is v already is subject, but I want to make this t here subject. So the first step is to remove the division by t. This division by t, remove it. So what I'm going to do is to multiply both sides by t. Understand? Multiply both sides. This division, remove it. So multiply both sides by t. You see, the first thing, this t has a division on it, but to remove it from under here, you multiply both sides by t. I gave you the rules. If one side is multiplied, the other side is divided. If one side is plus, the other side is minus, and so on. Okay, so when I do that, I will say v times t is equals to d over t times t. You see, what I'm writing here is what I've done here. This side of the equation is by t and by t. So I'm doing the same thing and I'm not changing anything. Remember, my initial equation is still there. V is equals to d over t is still there. What I did was to introduce that multiplication of t on both sides. Understand? And I'm not doing anything wrong. Okay, so when I do that, this one will now cancel this. So I have vt is equals to d. But our instruction is to make t is already a formula. So but t is not solid yet. T is still tied to v. What is binding t and v together is multiplication. And we have identified that thing binding them together. We're going to use the counter operation to detach it. That counter operation is division. So again, I will now say divide both sides by v so that v can be detached from t. Then we're making t subjects. So I'll say divide both sides by v, right? So I have it as vt over v. That's this side. Okay, let me just leave it like this so I know. Then it's equals to d over v. So this v cancels this v. So this one cannot cancel. what I have left now is now t is equals to d over v. Now we have succeeded in making t subject. Before, it was not subject, it was a variable inside here. But this variable that has now been brought out by simply using two operations. We inspected. Now, the rule is to look at what you want to bring out. I want to bring out t. The next thing, what operation is binding t inside that expression? The first thing here is that division is binding t. How do I remove that division? I will multiply both sides by t. So that division removes. The second thing again, what you have here, t is still binding to v. How do I remove t or detach v from t? I will look at it. I will divide both sides by v so that v can be detached from t. So when I'm done that, the final answer is t is equals to v over d. That's it. That's it. So again, I have another example on the board that we should make h the subject in this formula. So I have a is equals to half base times height, right? Now a currently is the subject, and I have base and height inside here, but the height is what I want to make subject. So I expect this side of the equation. That's the side of the equation. I expect the right side of the equation. I expect it. I look at it. I say, okay, what is binding h to this expression? What is binding it? It is multiplication, because there's a multiplication sign here and here. So what I will do is to use the inverse operation of multiplication, which is division. I will now say divide both sides by, okay, I will start with this one now because this is multiplication by b and multiplication by half, right? Right. But I will leave this half first and work on the b. So I'll say divide both sides by b. So I'll say a over b is equals to half bh over b. So this one and this one are the same, is the same thing. I'm doing the same thing here and same thing here. So this one will cancel this one. So I have a over b is equals to half h. Now, this is the same thing as saying h over 2, right? Because h times 1 is h, then over 2. Now, what is binding h to these two? It is this division sign here. So for me to remove it, I'll use the inverse operation, which is times or multiplication. I'll say multiply both sides by this one to remove this one from here. So I'll say multiply both sides by 2. So here, I will say on this side of the equation, I will say a over b or multiply by 2, or a over b multiply by 2 is equals to h over 2 multiplied by 2. See, the same 2 is here and here. Instead, I just added 2 on both sides, that multiplied 2 on both sides to the existing equation. So this one will cancel this. So I have 2a, that is 2a over b is equals to h. So h is not the subject standing alone. So that is the answer. So number 3, make arrow the subject. Make arrow the subject of formula. So arrow is here. Arrow is attached to two things. Attached to pi by multiplication, attached to 2, the power of 2 by square. Remember? So the first thing to do is to remove this multiplication first. So to remove this one, we say use the inverse operation of multiplication, right? We say divide both sides by pi, so that this one can be detached from this, right? So for this side of the equation, I have a over pi is equals to pi arrow square over pi. So I'm dividing both sides by pi. I'm not doing anything wrong. So this will cancel this. So I have a over pi is equals to r squared. Again, r is still attached to the power of 2. So how do I remove that power of 2? I'll now say find the square root of both sides. Find the square root of both sides. Find the square root of both sides. So for this side, I put the square root sign here. A over pi is equals to square root of this will cancel out eventually. So that is this square root will cancel this. In fact, this expression here is the same thing as saying r squared dot 1 over 2. So this square root is raised to the power of half, because raised to the power of half is square root. So 2 will cancel 2, I'll remain r. Therefore, root a over pi is equals to r, or r is equals to root a over pi. So the thing is that what you're making sure the formula should stand alone without being attached to any other variable. Okay, so make m the subject. So this is m inside here. Currently, f is the subject. F is a variable, but it's a dependent variable. Why m is inside here? These are constant terms, you understand? Now, I'm looking at this. So I want to make m stand alone. I want to detach minus 4 and over 3 from this. So the first thing I'll do, easier thing to do, is to look at this one that is down here. And I show that this 3 is attached to the whole of this expression with division, that is quotient or divided sign. So I will just use the inverse operation of division, which is multiplication. I will now say multiply both sides by 3. So on this side of the equation, f multiplies 3, and on this side of the equation, m minus 4 over 3 multiplies 3. See what I've done? I've multiplied both sides by 3. So this 3 will cancel this 3. So I have 3f, because this is commutative, I can associative, I can associate it, I can inverse where the position is, right? So it's equals to m minus 4, what is left of this side. So this is how the equation is now. But minus 4 is still attached to m, and I want to make m stand alone. So what I will do, minus 4, the minus sign in this minus 4, the inverse operation of that minus sign is plus. So I will say add 4 to both sides. Add 4 to both sides, so that I will remove this minus 4. So on this side of the equation, I have 3f, I'm adding 4 plus 4. And on this side of the equation, I'll write this one, m minus 4, then I'll add 4. You see? Look at what I'm adding. This one I'm adding 4 here, I'm adding 4 here. So the same thing. I will not add 4 here and add 3 here. You know, it's not, you are doing the same on both sides. So for this one now, minus 4 and plus 4 becomes 0. So I have 3f plus 4 is equals to m. So m is standing alone. That is subject's formula. So here I have make y subject. So make y subject. So where is y? On this side of the equation, you have y and you have y here. So you have y on both sides, not only on one side. So this one is more clumsier than what we used to have. But the first thing we do is to expand the left. You know, this is the left hand side and right hand side, right? So the first thing we do is to expand the left. Expansion means to take what is outside and multiply by each of these terms, still retaining the operation at the middle. So 4 times x is 4x, then minus 4 times y is 4y, is equals to 3y. What I've done here is to expand this, so I can have 3 separate terms, 1, 2, 3. Okay, so, but the second term, this one, 4y, and this third term, 3y, all have y together. So I can collect like terms. So to collect like terms is a process of making sure that terms or variables that are similar all be at one side. Understand? So for this one now to be with this guy, for this 4y to be with 3y, I will look at the operation that is here and use the inverse to operate on both sides. So I will say add 4y to both sides. Okay? So I will have 4x, then minus 4y, then I'll follow my instruction here, plus 4y is equals to 3y plus 4y. So I'm adding 4 to both sides. This is what is different in this equation. Okay, so this is, yes, this and this will cancel. Why? Because minus 4y plus 4y is 0. So I have 4x is equals to 3y plus 4y is 7y, because I can add the two of them together. The operation can be done together. So, but my goal is to make y subject to formula. So again, something is attaching to y, and this is 7. And what is binding 7 to y in this equation, or on this side of the expression, is multiplication. So I will now say, use the inverse of multiplication. I will say divide both sides. Divide both sides by 7. So here, I will now say 4x over 7 is equals to 7y over 7. See 7 here and 7 here. 7 cancels, and I have finally y, this is y, is equals to 4x over 7. So this is the new subject formula for that expression. So here we have make x subject to formula. So I have a is equals to 3x minus 2 over x plus 5. Now, the first thing we have to do, once we see something like fractional term like this, we can make it linear by saying multiply both sides. Okay, so this can be written like this. A over 1 is equals to 3x minus 2 over x plus 5. So this way can be written like this. Just make this one over 1. It's the same thing. So they are fractions. So I have fraction, numerator here and denominator here. And also on this side, I have numerator and denominator. Now, what we'll do to make this thing to be in a linear form, that is, with not being in a fractional form, to be in a whole number form. So I will multiply both sides by x plus 5. Multiply both sides by, or I will introduce you to the concept of what we call cross multiplication. Okay, so cross multiplication. What does that mean? Multiplication. Okay, so if you have two fractions equating each other, this fraction is equating this fraction. What it means is that I will take the numerator of this fraction on the left-hand side and multiply by the denominator of this fraction and keep it as the new left-hand side, and take this denominator of this fraction and multiply by the numerator of this fraction and keep the answer on the right-hand side. So cross multiply means that if I follow an arrow like this, it means that A is multiplying this. So I will say A, open bracket, x plus 5, close the bracket, then equals to, then this one multiply this one, 1, open bracket, 3x minus 2, close bracket. So multiplication is a process of trying to resolve fractions into whole numbers by taking the numerator of the first of this fraction on this left-hand side and multiplying by the denominator of the fraction on the right-hand side, and keep the answer on the new left-hand side, and take the denominator of the left-hand side and multiply by the numerator of the right-hand side, and keep the answer at the new right-hand side. So I've done that for this process. I will now have to open the bracket that expands. I will expand. So I'll put the word there, expand. So by expansion, it means that I'm going to multiply what is outside by what is inside, respectively. So a times x is ax, plus a times 5 is 5a, is equals to 1 times 3 is 3x, and 1 times 2 is minus 2. So I have done that. My goal is to also make is to make x subject to formula. Let's not forget that goal. Where is x? I have 4 terms in this equation. 1, 2, 3, 4. X is present in the first term and in the third term. So I'm going to group them together by collecting like terms. Collecting like terms. Collecting like terms. Okay, so at this point in this particular video, I'm going to let you know that when a term is crossing this equality sign to go and meet the like term, the operation is crossing will change to the opposite operation. Okay, so let me write it down. This is ax. Ax is still standing here. My intention is to make 3x cross to the other side. 3x is crossing, but it's crossing with plus. There's a plus sign here, right? It's a plus sign here, plus operation. But by the time it crosses, it takes the opposite operation, which is minus. So when it crosses, it becomes minus 3x, right? Then it's equals to, this is equals to sign here. I have minus 2 still here, left here. but 5a, we have to cross. When 5a plus 5a is crossing the equality sign, it becomes minus 5a. Okay, so I've done that. So I have used these collecting like terms to group the x that I have in mind to bring out, to make it a subject. So I have x inside this first term and x inside the second term. So I need to factorize so that the x can come outside. So x is common, right? So I'll just put x outside, and the open bracket, what's left of a and x is a, minus what's left with 3 and x is 3, such that if I say x times a, I'll have ax, and x times minus 3, I'll have 3x. So this is what I've resolved from this. So for this one, I can still leave it like that. I can say minus 2 minus 5a. Okay, so now my goal is to make a sort of formula, but x is still being attached to this particular one by multiplication operation. So to detach this, I'll just say divide both sides. So multiplication, the opposite operation is division. So I'll say divide both sides by a minus 3. So I'll write this side first, which is x open bracket a minus 3 all over a minus 3 is equals to, this one is minus 2 plus 5a all over a minus 3. You see, what I did here, I'll just open a bracket and put plus in the center. This is the same thing as this one, right? Okay, so a minus 3, I have x is equals to minus a plus, minus 2 plus 5a all over a minus 3. So this is the final answer. I've made x subject to formula, transforming it from this kind of equation to this kind of equation. So I'm going to leave you with this particular past question, IGCSE past question. It says t is equals to 4r minus 1 all over 3. So make r subject. So you see where r is now, and what's attached to r is 3 divided by 3 and minus 1, right? So I will still write this by like this, t over 1 is equals to 4r minus 1 over 3. So the first thing I have to do is to make them linear is to cross multiply, cross multiply, cross multiply. Mind you, in cross multiplication, this numerator here multiplies the denominator here. So I have 3t is equals to this denominator here multiplies the numerator here, 1 open bracket 4r minus 1. Okay, so at this point I will just open the bracket up. I'll have 3t is equals to 4r minus 1. Our goal is to make r subjects. So what is binding r to this expression is minus 1 first. So I will say add 1 to both sides, or I will say when minus 1 crossed to meet this one, it becomes plus, right? So I have 3t plus 1 is equals to 4r. Again, I have r attached to 4, right? I will say to make this 4 disappear or detach from r, I'm going to do an operation that is opposite the operation that's binding two of them. The operation binding two of them is multiplication. So I'm going to divide both sides by 4. Division is the opposite of multiplication. So I will say divide both sides by 4. So I have 3t plus 1 over 4 is equals to 4r over 4. 4 cancels 4. Therefore, 3t plus 1 over 4 is equals to r. R, this is the final answer. That is the subject's formula. All right. So I hope this video has been informative for you. I'd like to thank you for viewing. Kindly subscribe to our channel and share this video to get everybody to watch it. Thank you.